It's hard to ignore how much AI is popping up everywhere these days, right?
Oh, absolutely.
From helping with work tasks to, generating creative content, it feels like we're constantly hearing about something new. Staying on top of it can be, well, a real challenge.
It really can. The speed it's evolving at is quite something.
Yeah.
And even just the vocabulary around it can feel like a whole other language sometimes.
Mm.
And that's why taking a focused look, a deep dive into what's really important is so useful.
And that's precisely what we're doing here. We want to get beyond the buzzwords, the hype,
Right.
to really understand the core ideas behind artificial intelligence. And also this really vital skill, how to communicate effectively with AI systems.
Crucial.
So for this, we've gathered quite a range of material. We've got introductory guides, articles on prompt engineering, how to phrase requests,
Yeah.
how AI developers communicate, some interesting YouTube perspectives on AI and creativity, and even some real-world discussions from Reddit about how non-technical people are getting involved.
That's a good mix. And our goal here is pretty straightforward. We want to give you, the listener, a clear, easy-to-grasp overview of what AI is really all about and how you can practically interact with it.
Mm-hmm.
We want to pull out the key knowledge, the insights, so you come away feeling informed, confident, and hopefully not totally overwhelmed by the technical stuff.
Okay, so let's start right at the beginning. When we talk about artificial intelligence, what are we actually talking about? What does that mean?
Well, at its heart, AI is really about enabling machines to perform tasks that, typically require human smarts.
Okay.
Things like figuring things out, learning from experience, solving problems, understanding language, both spoken and written. It's a huge field, actually, with a history that might surprise some people.
Exactly. It's not some brand new thing that just appeared overnight, is it?
Yeah.
I remember reading a bit about its origins.
That's right. The idea of intelligent machines, it really took hold sort of mid-last century, around the 1940s, 50s. A really key moment was in the 50s when John McCarthy, often called the father of AI, he actually coined the term artificial intelligence.
Ah, okay.
There was a lot of initial excitement, but progress wasn't always smooth. It had its ups and downs. We even had periods called AI winters.
AI winters? That sounds a bit dramatic. What were those?
Well, they happened in the 70s and then again later. Basically, funding and interest just sort of dried up when some of the early, really big promises didn't quite pan out as quickly as people hoped.
Ah, expectations versus reality.
Exactly. The AI winters weren't just about slow progress. They really highlighted that gap between the big ideas and what the tech could actually do at the time. It's kind of a classic tech story, really managing expectations, focusing on what's genuinely achievable.
Interesting. So what brought AI back? What sparked the recent boom?
The last couple of decades have seen a real comeback, a sort of reinvention maybe in the 2000s, and then a full-on renaissance in the 2010s.
Yeah.
And this was largely fueled by huge advancements in machine learning and, crucially, the massive amounts of data we suddenly had access to.
Okay, which leads us perfectly into machine learning and deep learning. We hear these terms constantly. Are they just different words for AI?
Not exactly. Think of AI as the overall umbrella goal, creating machines that can think or act intelligently.
Got it.
Machine learning is one of the main ways we try to achieve that goal. So instead of giving computers explicit instructions for every single possible situation,
Right.
we feed them enormous amounts of data and let them learn the patterns from that data.
Okay, like that example we saw. Building an AI to spot fraudulent insurance claims by just showing it tons and tons of examples of real claims and fake ones.
Precisely. The AI learns to recognize the subtle patterns, the clues that indicate fraud, just by analyzing all that data. This is really different from older rule-based systems.
How so?
Well, with the rule-based system, you'd have to sit down and program specific rules like, if the claim amount is over X and submitted less than Y days after the policy started, then flag it.
Okay, very rigid.
Very rigid. Machine learning can find much more subtle, complex connections in the data that a human might miss. And crucially, unlike those fixed rules that only catch known fraud types, machine learning can adapt. It can spot new patterns of fraud as they emerge. It's way more dynamic.
That makes sense. And deep learning, where does that fit in?
Deep learning is a more specialized type of machine learning. It uses these things called artificial neural networks, but with many, many layers, hence the term deep.
Ah.
These deep networks are particularly good at learning really complex features and patterns from data. They've driven huge breakthroughs in areas like recognizing images and understanding natural language.
So just to recap, AI is the broad goal. Machine learning is a key method to get there by learning from data, and deep learning is a specific, powerful type of machine learning using these deep neural networks.
You've got it.
Okay. Now, you mentioned natural language processing and computer vision earlier. These sound like really important subfields within AI.
Oh, absolutely fundamental. Natural language processing, NLP for short, is all about enabling computers to understand, interpret, and even generate human language.
Like chatbots.
Exactly. Chatbots understanding your questions, translation tools, AI that can summarize long articles for you. That's all NLP.
And how does it work, roughly?
Well, often it involves pre-processing the text first. Things like making all the letters lowercase, breaking sentences into individual words, or even smaller pieces called tokens.
Tokens, okay.
Yeah, sometimes AI breaks words down further, and also reducing words to their root form, like running becomes run.
Ah, so it treats related words similarly. That makes sense. You wouldn't want run and running to seem totally different.
Precisely. And then you have techniques like named entity recognition, or NER.
But
That's about identifying specific things in the text names of people, organizations, locations, dates. It helps the machine understand the context.
okay.
And then there are question answering systems. Imagine asking an AI a question about a news article. An extractive system would literally find the sentence with the answer and pull it out.
Oh,
But an abstractive system is more advanced. It understands the information and generates a new answer in its own words. These can range from finding answers in just one document to pulling info from vast knowledge bases.
fascinating. So NLP is about language. Computer vision, then, must be about letting computers see.
You nailed it. Computer vision lets machines interpret and understand information from images and videos. We see this everywhere. Object recognition, like traffic cameras identifying cars, trucks, bikes, and facial recognition. It's kind of wild to think a computer can see a face and know who it is.
Is there a difference there, just spotting a face versus knowing whose face?
Yes, absolutely. That's a key distinction. Face detection is just finding a face saying, yep, there's a face in this picture. Face recognition goes further. It tries to identify who that face belongs to by matching it against a database. And computer vision is being used in really critical areas too, like analyzing medical scams in radiology, for example. Though, of course, there are challenges. Things like getting enough high-quality data to train the models, ensuring accuracy, and making sure we can understand why the AI made a particular diagnosis. That's interpretability.
Right. Important stuff. Okay, we're covering a lot. One more big term that's constantly in the news, generative AI. What's that all about?
Generative AI. Yeah, that's a really exciting area. It's focused on AI models that can create new, original content.
Create, like what?
Pretty much anything. Text, like writing articles or code, images, video, music.
Yeah.
These models learn the underlying patterns and structures from massive data sets, like vast amounts of text and images from the internet.
How do they learn to create, though?
It's complex, but one common technique is basically learning to predict the next piece of information. For text, it might be guess the next word. It makes a guess, compares it to the real data, sees how far off it was, and adjusts itself slightly. This process, often involving human feedback too, repeats millions of times until it gets really good at generating coherent, novel stuff.
So it learns the patterns and then uses them to make something new.
In essence, yes. But it's often more than just remixing. It can produce genuinely creative and surprising outputs. We're seeing different types too, text-to-text models, text-image, text-to-video.
Right.
And the trend is towards multimodal AI, where one system can understand and generate multiple types of content, like understanding both text and images and creating either.
That's incredible. Okay, one last technical bit you had noted. Knowledge representation. Sounds heavy.
It is a bit more on the theoretical computer science side, yeah. But it's basically about how we structure and organize information so that AI systems can understand it and, importantly, reason with it.
Like how the AI organizes its thoughts.
Sort of. Think of it as building the AI's internal library or knowledge base in a structured way. There are different methods, like semantic networks, which are kind of like mind maps showing how concepts are related, or using formal logic, like predicate logic, to represent facts and rules, or even things like production rules, which are like simple if-then statements.
Okay, so ways to make knowledge usable for the machine. Got it. We've definitely demystified some core concepts. Now let's pivot to how we actually interact with these systems. That's where prompt engineering comes in, isn't it?
Exactly. Prompt engineering is fast becoming a really crucial skill for almost anyone using AI.
Why is this so important?
because the way you phrase your instruction or question your prompt has a massive impact on the quality and relevance of the AI's response. It's all about bridging that gap, overcoming what some call the articulation barrier.
The articulation barrier.
Yeah, the difficulty we sometimes have in clearly explaining exactly what we need or want the AI to do. A good prompt helps the AI understand your intent much better.
You had a great example in the notes about asking for high tide times. Can you share that?
Sure. If you just ask an AI, when is high tide? Well, that's pretty useless, isn't it?
Right. Where? When?
Exactly. Tides depend massively on location and date. A much, much better prompt would be something specific like, what are the high tide times in San Francisco, California on July 15th, 2024?
Ah, much clearer.
The specificity makes all the difference. More details help the AI zero in on exactly what you need and give you a useful, accurate answer.
That makes perfect sense. So apart from specificity, what else should we keep in mind when crafting prompts?
Well, our sources highlighted a few things. One is prompt length. It's not always about super short prompts being best. While some systems might have character limits, for many large language models, the issue isn't a hard limit. It's more that very long, rambling prompts can sometimes bury the main point or introduce confusion. But it's tricky because these models think in tokens, not words or characters per se.
Tokens again.
Yeah, so telling them keep it under 50 words might be harder for them than saying give a short summary or explain in 2 sentences. They grasp the intent better than precise counts sometimes.
Interesting nuance. What else?
Avoiding ambiguity and conflicting terms is key.
Like what?
Like asking for a detailed summary? Those words kind of pull in opposite directions, don't they?
Yeah, detailed and summary.
It can confuse the model about whether you want conciseness or comprehensiveness. Being clear and direct with what you want is usually the best approach.
Okay. Now, writing prompts for text makes a certain amount of sense. But how different is it when you're trying to get an AI to generate an image?
Image generation often requires even more descriptive prompts. It's not usually enough to just say a cat.
Right.
You typically need to describe the scene, specific details about the cat, its breed, color, pose, maybe the mood or atmosphere you want, happy, mysterious, dramatic. The artistic style is huge, photorealistic, cartoon, watercolor painting, Van Gogh style.
Wow.
Then there's framing, close-up, wide shot, lighting, sunny day, dimly lit room, golden hour, specific colors, the level of realism. All these details help the AI translate your mental image into pixels.
That's definitely more involved than just asking it to write a paragraph.
It really is.
Yeah.
And because translating complex visual ideas into just the right words can be tricky for anyone,
Yeah.
this idea of prompt augmentation is becoming really helpful.
Prompt augmentation. What's that exactly?
It basically refers to features and tools within AI systems that help users refine, improve, or modify their prompts to get better results. It's all about making it easier to get your idea across to the AI, overcoming that articulation barrier we mentioned.
Okay, tools to help write better prompts.
Exactly. And our sources laid out 6 main ways or design patterns for how these tools work.
6. Okay, interesting. Let's hear them.
All right, first up is style galleries. You see this a lot with image generators. They show you visual examples of different styles, maybe cinematic, anime, vector art.
Like a menu of looks.
Precisely. It gives you both inspiration and the actual words to use in your prompt to achieve that look. Super practical.
Okay, that makes sense. What's number 2?
Second is prompt rewrite. This is where the AI takes your basic prompt and suggests ways to make it richer or more detailed. You might type dog running, and it suggests golden retriever happily running through a sunny field action shot.
Oh, so the AI itself enhances your prompt. Clever.
Yeah, helps you flesh out the idea. Third is similar but more controlled. Targeted prompt rewrite.
Targeted.
Here, you tell the AI a specific way you want the prompt changed. So you have your image prompt, and you might click a button or instruct it to, say, add dramatic lighting or make it cyberpunk style.
Okay, so you guide the rewrite more directly. Got it. Number 4.
Number 4 is related prompts. The AI looks at what you asked for and suggests other related prompts you might be interested in. If you're asking about renewable energy, it might suggest follow-up questions about solar panel efficiency or wind turbine costs.
Like suggested searches, but for prompts. Could spark new ideas.
Definitely. Fifth is prompt builders. These are more structured interfaces, less free-form text. Think drop-down menus, checkboxes, specific fields to fill in for different parameters.
Like filling out a form to build the prompt.
Kind of, yeah. You might see this for more technical things like generating code or maybe specifying complex scene elements for video generation, like camera movements.
Okay. And the last one, number 6.
The final one is parameterization. This is often a hybrid approach. You might have a text box for the main prompt, but then also sliders or other controls to adjust specific aspects.
Sliders. Like what?
For text, maybe a slider for formality or reading level. For image generation, sliders for stylization or chaos. For voice generation, sliders for stability or clarity. It gives you this fine-grained, often visual control to tweak the output.
Wow, those augmentation tools sound incredibly useful, especially for people who aren't, professional prompt writers.
Absolutely. They lower the barrier to entry and help everyone communicate more effectively with these AI tools.
Which brings us nicely to this idea of AI literacy, especially for non-technical professionals. Why is that becoming so important?
Well, in a world where AI is just increasingly woven into the fabric of work and life,
Right.
AI literacy is becoming a fundamental skill. It's not about needing to code AI models yourself. It's about having the basic knowledge to understand what AI is, what it can realistically do, how to use the tools effectively, and also being aware of its limitations and potential pitfalls.
So being an informed user and citizen.
Exactly. It empowers people. Our sources broke it down into 3 core modes or aspects.
Okay.
First is understand, just getting a basic grasp of AI concepts, its capabilities, how it generally works. No deep tech needed, just the fundamentals.
Right.
Second is evaluate, being able to think critically about AI. When is it helpful? What are the potential downsides? Considering ethical implications, potential biases.
Critical thinking.
And third is use, actually interacting with AI tools, knowing how to use them for practical tasks, problem solving, maybe even creativity.
So it's understand, evaluate, use. A good framework. It's not just knowing how to click the buttons, but why and when.
Precisely. And the good news is there are more and more user-friendly AI tools out there for people who aren't tech wizards. We've mentioned things like ChatGPT for drafting emails or summarizing reports.
Yeah.
But also AI features being built right into software people already use, like Microsoft 365's Copilot. There are tools for automating data analysis and creating visualizations, and even no-code platforms where you can build simple AI applications without writing a line of code.
It really does sound like AI is becoming more accessible. Okay, let's shift gears slightly, though. While AI offers all this amazing potential, we do need to be mindful users, right?
Right.
What are some of the critical considerations?
Absolutely. Using AI responsibly is huge. And maybe the most discussed issue is bias.
Bias in AI, how does that happen?
Well, remember we said AI learns from data.
Right. Massive amounts of data.
If that data reflects historical biases present in society, and often it does, the AI can learn and even amplify those biases.
Can you give an example?
Sure. If hiring data from the past shows mostly men were hired for certain roles, an AI trained on that data might learn to favor male candidates, even if gender isn't explicitly mentioned. We've seen examples related to gender bias in jobs, racial bias in things like facial recognition or even loan applications, age bias, geographical bias where healthcare AI might work better for populations whose data was more represented, language bias and sentiment analysis, even biases in medical diagnoses if the training data wasn't diverse enough.
There was that example in the notes, too, about image labels from social media.
Yes, that was striking. Analyzing labels applied to images of men versus women often showed stereotypes reflected in the AI's understanding. Men more associated with professional roles or activities, women more with appearance or domestic settings.
So the AI just learns the biases that are already out there in the data.
Often, yes. That's why measuring and detecting bias is a big area of research using fairness metrics, comparing how the AI performs for different demographic groups, things like that.
Okay. What else besides bias?
Transparency is another big one. Understanding why an AI made a particular decision. This is often called explainability. It's crucial for building trust and accountability, especially in high-stakes areas like healthcare or finance.
Makes sense. You want to know how to reach that conclusion.
Exactly. Then there are ethical concerns around privacy and data protection. When AI uses personal data, how is it protected? Are people informed? Is consent obtained? Techniques like anonymization and encryption are important, and there are advanced methods like differential privacy.
Differential privacy.
Yeah, it's a mathematical technique to add noise to data in a clever way, so you can still analyze trends in the overall data set, but protect the privacy of any single individual within it. It's about finding that balance.
Okay. Anything else on the critical side?
Well, there's the issue of adversarial attacks, basically, ways people try to trick AI models into making mistakes, sometimes with tiny, almost invisible changes to the input.
Vulnerabilities.
Yeah. And ensuring inclusivity is vital, making sure AI systems treat diverse groups fairly and equitably. Then there's robustness and reliability. Does the AI perform consistently well under different conditions? Or does its performance degrade if the real-world data starts to look different from its training data? That's called concept drift or data drift.
Lots to consider.
One more is emerging too. Sustainability or green AI. Training these massive AI models takes enormous amounts of energy and computing power, raising environmental concern.
Right, the carbon footprint of AI.
Exactly. So there's a push towards more energy-efficient models and training methods.
So bias, transparency, privacy, security, inclusivity, reliability, sustainability. It's a complex picture.
It is, and it all underscores that while AI tools are incredibly powerful, they aren't magic. Human oversight, critical thinking, ethical awareness, these remain absolutely essential. As some sources noted, humans still bring the inspiration, the goals, the ethical framework to the AI.
That's a great point. It's a collaboration, not a replacement. Okay, this has been incredibly insightful. Just to quickly wrap up the key takeaways.
Sure.
We've seen AI is this really multifaceted field with a surprisingly long history and incredibly diverse applications now, from understanding language with NLP to seeing with computer vision.
Right. And we've stressed how crucial effective communication is, crafting good prompts, maybe using those augmentation tools to really harness AI's power effectively.
Definitely. And finally, the importance of engaging, critically understanding the potential for bias, the need for transparency, all those ethical considerations. AI literacy isn't just useful, it feels essential now.
Absolutely. It's about navigating this evolving landscape wisely.
So here's a final thought for you, the listener, to maybe mull over. Think about the principles you use for clear communication and critical thinking in your everyday human interactions. How can you apply those same principles when you engage with AI? As you become a more fluent conversationalist with these intelligent systems, what new possibilities might open up for you?
That's a brilliant question to ponder. We really encourage everyone to keep exploring these concepts and resources. The more you understand AI, the better equipped you'll be to use it thoughtfully and effectively.